Chapter 11 is on intermolecular forces. And the first section that we're going to cover, 11.1, is on the kinetic molecular theory of liquids and solids. And a lot of the content in this first section is review from stuff that you learned in 161, in the very beginning of the fall quarter. In the beginning of the fall quarter, one of the first things that you learned about was solids, liquids, and gases, and the way that they are different in terms of their volume and shape and things like that. And so we're going to start this chapter with a refresher on the differences between solids and liquids and gases, and we're going to add some new information to the information that you already have about solids, liquids, and gases. I'm going to make a data table. We're going to be comparing solids and liquids and gases in 5 different areas. First thing that we're going to look at is the volume of a solid, a liquid, and a gas, and this is something that you learned in 161. For solids and liquids, we say that the volume is fixed. Of course, this isn't completely true. Solids and liquids do have slightly variable volumes. With temperature, the volume will change. For most people, it's sufficient to just say that the volume of a solid and the volume of a liquid is fixed, because the amount that it changes is pretty small. But for engineers, people that build bridges, people that build airplanes, things like that, those kind of scientists need to know that the volumes will change with temperature of solids and liquids. So we'll say fixed because most people don't need to know it, but we'll put quotation marks around it for the future engineers. The volume of a gas, you learned, is variable. It is very easy to compress a gas, to make it smaller, or to expand it, make it bigger. You also, in 161, learned about the shape of solids, liquids, and gases. You learned that solids have their own fixed, definable shape. That means that the shape of my pen is this shape, the shape of a pen, no matter what kind of container it's in. If I put it into a glass, its shape isn't going to change. If I put it into a box, its shape won't change. Liquids and gases, you learned, will take the shape of their container. And you also learned in 161 the difference in the molecular motion for all of these states of matter. And you learned that solids have very slow molecular motion. They're often described as vibrations in place, meaning that the molecules or the atoms in a solid, they don't really move around inside the sample. They stay put in one spot and they just kind of wiggle in place. They don't go all over the place. So they just vibrate in place, but they are constantly moving. Liquid molecules or atoms are in constant contact with each other. They don't separate from each other, but they're not stuck in place. If you can visualize, if we had like a big jar of marbles right here, the marbles would all be in constant contact, touching each other. You wouldn't have one marble that's hovering above the rest of them. They're all going to be packed together. But they aren't stuck. The marble that's down at the bottom of the jar isn't stuck down at the bottom of the jar. It can, if you shake the container, that marble can work its way up to the top. Or a marble that's on the right side of the container isn't stuck over there. It could wiggle its way over to the left side of the container. And that is how the motion, that's a good way to describe the motion of a liquid. The molecules or the atoms are in constant contact with each other, but they're free to move around. As long as they stay in contact with each other, that's okay. The gases, on the other hand, have very fast motion. It's random, sometimes described as flying. They don't fly. And the molecules are not in contact. You learned in 161 in the gas chapter that the motion of a gas is random, meaning that there isn't anything that's pulling them in one particular direction. And you also learn that that's kind of not true, but it's a good enough thing to say. So they have fast flying motion, and that I always like to describe the motion of a gas as if you had a handful of super balls and you just threw them as hard as you could against the wall, and the super balls would bounce all over the place, and that would be like that's how I imagine a gas. We're going to add two things to this chart, two things that are new this quarter, and they're going to be intuitive, they're not going to be tricky. The next thing that we're going to talk about is density, and we're going to talk just about the relative density of solids, liquids, and gases. Because, as you learned last quarter, there's a lot of variation in the density of even a bunch of different solid substances. And what we're going to say about this is that the density of solids and liquids is high in comparison to the density of gases, which is very low. And that's all that we're going to say. And that makes total sense because you learned last quarter there's a lot of empty space in the sample of a gas, and all that empty space gives rise to a really low density. Small mass taking up a big, huge space is going to give you a low density. And again, these are just relative terms. There are some solids that have lower densities than others, but the density of a solid is always going to be high compared to the density of a gas. And the density of a liquid is always going to be high compared to the density of a gas. And that's all we're trying to say here. And the last thing that we're going to talk about is compressibility. And compressibility relates to density as well. For a solid, because if you imagine what the solid looks like at the molecular level, remember we have all of the atoms packed side by side together as closely as they can possibly be. And because everything is already packed close and tight together in a solid, we'll say that a solid is not compressible. That's not totally true. Again, for the engineers, you can smash them a little bit or expand them a little bit. But for the most part, all the atoms in a solid are as close together as they're ever going to be, and you can't smash them any closer together than they already are. Liquids have a tiny bit of compressibility. I'm going to write that, tiny bit. Liquids, like solids, for the most part, they're as tightly packed as they can be. All the molecules are in constant contact with each other. It turns out you can smoosh them a little bit closer together than they already are, but not very much. They're not very compressible. Gases, on the other hand, have very high compressibility. There's so much empty space in an example of a gas that it's very easy for you to take the gas sample and compress it, smash it into a smaller volume.